Hello everyone, and in this lesson we're going to take a look at how to use the new Photon tracer in Octane to generate caustics. So this isn't new, but it's been added in the latest version, so which has been out for about I guess 5-6 months, maybe a little more. Anyways, so I have like this looks a little too much because I have like a whole bunch of things in here. But what I have is I have a simple base and I made a prism which is basically just a tube. Okay, so it's a tube with three sides and I gave it some normals. And then lastly, I have made a light. Okay, now we are going to use the Solaris lights as well. But for now, just as an example, I also made like a spotlight because what I want is I want a very narrow beam of light in order to generate caustics, which is if you're going to generate caustics, you should either use the sunlight or a direct light because you want like a very sharp beam of light. If it's too diffuse, it'll just blur out everything. So what I have here is I just built like a box, like a hollow box, and then I gave it two different materials. So I have like one material which is for the inside and then another one for the body. Okay, now I also have a material library where I don't need these guys, so I'll get rid of this. I also have a volume which I will talk about a little later. Okay, so what I have is I have a very simple glass material, yeah, but we'll build a new one. Okay, so what I'll do is I'll just take, you can take a standard shader. So just take, we'll just take a material standard surface and just plug it in. And for now, I'll just turn this into glass. So what I'll do is I'll get the base weight to 0. If you're coming from Arnold, this is pretty much the same thing. So get the base weight to 0, get the transmission weight to 1, get the specular roughness. Okay, we'll keep it at 0.2 for now. It's not going to help, but we'll keep it at 0.2 and then we'll come back. Okay, so this is my prism material. And then I have a light shader, which is just a simple emission texture connected to a diffuse. And I have a body material which is completely black. So I don't want, like, that is going to be assigned to the box. So I don't want any light bounces or some color bleed coming from there. And I have a base. So the base is again just a simple like a white or actually like a medium dark gray. Okay, so I've assigned these materials. So what I have right now is I've assigned the black color to the body and then the light material to the inside plane. And then there's a material assigned to the base. And I have my render settings, which are currently kept at path tracing in Octane. Okay, now I am using the Solaris version. All of this will work with the standard version as well. So all of these settings are exactly the same. I have an HDR environment, which I've just kept to gray, like a light gray for now. And in the path tracer, these are default settings. So I'll just keep this down to 5, the GI clamp, and diffuse. Okay, let's just keep this to like 3 and 3 and 3. And I can just hit render and see what we get. So this is what we have. Okay, so it's like super bright because I needed the beam to be super bright. So what I'll start off with is I'm going to take the HDR and make it, or like the environment color and make it really dark. And in order to get like a narrow beam of light, what you can do is just take the light and squeeze it. Okay, in the Z axis, I'll make it like 0.02. So it'll be like really, really fine. Okay, now what I can do is I can just take the prism and I'll just turn on the material for it. So which should give me glass. And there you go. So you have, you have glass. Now, traditionally what you do is if you are in, if you're using Octane in like a very standard way, in the material you have something called as fake shadows. If you turn that on, see now the light just passes through that. So it doesn't refract or anything, it just passes through it. Now, if you want to start generating caustics, the first rule is you want to turn on allow caustics. Okay, so just turn that on. It's not going to do anything because it doesn't work in the path tracer. So what you want to do is come here to render settings and change the kernel from path tracing to photon tracer. And that's pretty much it. You won't have to do much of anything else. And let's just hit render and see what we get. So if I turn on Octane, see you're getting like something. Now the problem here is that the standard depth uh, parameters that you get, like diffuse, specular, and scatter, they don't apply to the caustics. Okay, like if I, like right now we are generating caustics, like that stuff is very much caustics. Like if I come into the material and I turn off the allow caustics, you'll see like that's what you're getting. So you turn that on, you get caustics. So the thing is that the caustics has a separate depth value altogether. So if you come down, you'll find a area called photons, and there's something called photon depth. Now, if you're doing glass, you usually want to keep it around 4 or 5. So we'll keep it about 5. And there you go. See, so now the light sort of passes through that. So it's pretty straightforward. Like you don't need to do too much. And then if I come into my prism and I try to like rotate it or something, see, you'll get like, it's actually pretty fast. Now, I haven't compared this to anything else, so I don't know how fast is it in comparison to like say redshift or whatever. The only difference is that it shows the photons interactively, so it looks more fun. So here again, as I said, like the size of the light is very important. Like if I make this like 0.5, then the light is too big, everything just diffuses out. Like if I come into my light and let's just make it lesser. See, so now you're still getting caustics, but it just diffuses out the whole thing. So you're not getting like much of anything. Okay. So, which is why you want to like squeeze it down a lot so that you get like a really fine beam. See, so that is better. Okay, now you can also like, if you want to have fun, you can just come in here and we can give it some dispersion. So I can just come in here, and now this is where it becomes important. Like your specular roughness is important. Like right now it's because the roughness is high, the caustics will blur out. So if you bring it down, let's say 0.01, see, there you go. Now you have better caustics. Actually 0 is what you want, but sometimes that causes like fireflies. So like a little bit of roughness is fine, like 0.005 is okay. Also, the index of refraction will now start to give you, so you can actually run like a science experiment with this. Like it's actually that fast and that good. Okay, so it works pretty well. And then you can give it a little bit of dispersion. See, so it looks pretty fancy overall. Okay, so let's say if I take it up to about like 5 or 6, and then you can sort of add in more. So what I did was I had like a whole bunch of them, which I had sort of placed all over. And in the material, what I have done is that I have put in like, this is called prism 1. Okay. And like 2, 3, 4, 5. So what I've done is I've just taken like prism star. So anything that is named prism will get the prism material. So it becomes easier. So I can just, let's say I take this, I'll plug this in here. I'll disconnect that and I'll just bring back, like all of these. And what you'll end up getting is this. Now, if all I have to do is like adjust my IOR value to get something more interesting. So I'll just lower this down to around 1.33. And now the problem that's happening is we still don't have enough depth, because now we have like, if I go to my Houdini, see, so I have like these many spread out. So you need more photon depth in order for it to calculate all of it. So what I do is I'll come back here to my photon depth and let's just bring this up to 16 is the max, but there you go. Like, so now you can actually get like a full-blown science experiment. See, so if I zoom out, you can actually get like a pretty good result out of it. Now, if you don't want to use like this box light, which I have made, you can use the standard Solaris lights as well, because now it supports the spotlight and all of those options. So what I can do is, let's say if I just create a light, okay, the only rule is that I think it only works with disk for now. Okay, so just take this and I'll just bring it out here. I'll set this to disk and let's set this to Octane. Yeah, I'll temporarily disconnect the light here and let's just increase the intensity. Yeah, so I know which side it's going. Okay, so I can just turn this around. Yeah, so we're getting, see, we're getting caustics. Now what I can do is, I can come into shaping, I can turn on spotlight and I can just lower that. And then you can also take the radius and make it like 0.02. So it's like really small. I can turn on normalize power. Yeah, there you go. So that is good. And then you can take the barn door, like the left and right, and sort of just squeeze it in. So it just like, let's just turn off caustics for a second. So I can just see the light. Yeah, so I'll just come into material and turn off allow caustics. Yeah. Okay, so what the barn door will allow is you can actually like, see, I can actually just, like squeeze it in. So I'll get this to 0.3 and get the right one also to 0.3. So you just have like, like a fine beam of light. And now if we turn on cost, so this will like, you won't get too much blurring in the light. So it will give you better caustics. So now if I turn on allow caustics, see, there you go. Okay, so that's a lot better now than what you were getting. We could probably also take this and make it 0.01. Yeah, okay. And just, like we can bump up the exposure a little. I think I should squeeze it in a bit more. Yeah, okay. And then just, jump up everything. Let's make it 20. Okay, that's too much. But yeah, it does generate caustics pretty fast. So you can actually like play around with it a lot and get, whatever result you want. Okay. So yeah, so if I come into like any of these and I try to like rotate them, you can get different results. Like, it's really fun to play with. Like that's a really nice thing about it. Like we have this beam. Yeah, let's take this one and let's place it. Yeah, see, there you go. So if I take it and I place it where that blue beam is, so you can like refract that more. So anyways, caustics. Now, the few things that are important about caustics, which will be a little difficult to explain here, but you have these 4 parameters. Okay, so photon gathering is the size of the photon. Okay, so if I make it too big, the caustics will blur out a lot. Okay, it will go faster, but it will blur out a lot. And then the photon count multiplier is sort of like a ratio between how many photon rays it does and how many like standard rays or how many max samples it is doing. So if you kind of lower it a lot, it will take longer to sort of clear up. Like it will try to balance between, the standard ray tracing that is happening with the photon tracing that is happening. Now, if I increase it too much, you'll see like the photons will clean up faster, but it'll take the standard part tracing a little longer to catch up. So if I get it around like if I get it around like 4, you'll see like now these are starting to clean up a lot faster. Like this is taking longer, okay, or the amount of time it was taking before, but the photons have cleaned up pretty fast. So you can usually find like a balance between, the smaller the photons are, the longer it will take to calculate, okay, or the longer it will take to clean up. Okay, like if this is slightly bigger, it will smoothen out faster. See, like this tends to smoothen out a lot faster. Okay, now if we replace this, like let's do one thing. Let's get rid of, like these guys. And I have a simple model of a dog. So I can just plug that in over here. Yeah, let me just come into Houdini. See, there you go. So I have like a simple model of a dog. And what I'll do is I'll come into material, and I think I have a material for it. So I'll just turn off the prism because the prisms are gone. I'll just turn on where's the dog? Yeah, dog. And then I can just turn on Octane, and there you go, like this huge explosion of light. What I'll do is I'll just get rid of the dispersion. The dispersion will take, like if you have dispersion, it's going to take longer to clean up. So we'll just take the dispersion to 0. See, that cleans up a lot faster. And maybe I can just give it some thickness. So I'll just make this like, let's say we'll make it red I'll give it some transmission depth. Yeah. And if I take this light and yeah, maybe that's too red. Yeah, let's lower the intensity of the light because I guess it's a bit too much. Yeah, so here you can like again, you'll be able to see it easier. So if I like zoom in a bit, and you can see like if I lower the photon gathering, see now you're getting a lot more detail, but it'll take longer to clean up. And if I like increase that a lot, see it becomes very, very soft. So yeah, so you have to sort of find your balance, like speed compared to how much detail you want. And see, so as the photon count multiplier goes down, it remains grainier longer. So what happens is like everything can render at the same time. Like if I get it really low, see, so now this and the path tracing is sort of running side by side. But if I like jump it up a lot, you'll see like the caustics get cleaned very quickly and the rest of the path tracing is sort of still catching up with it. Okay, now as a final thing, let's do an example for like water caustics. So what I'll do is I'm going to get rid of the dog and I have this one setup. So what I did was I made like a box, which is nothing, which is just this. And I used a grid, like it's a pretty big grid, it's like 100 by 100. And I use like a ocean spectrum and ocean evaluate to generate waves. So I have, that. So I'm using both those things combined to make like a water inside a box. Like if I zoom in here, see, so I just have this. So what I'll do is I'll just import these two guys over there. Okay, like I'll get rid of, I won't use this. I'll make a new one. So I can just take a SOP import and I'll call this box. And I'll call this waves and we'll just pick those up. So box and waves. Okay, so I can merge these together and plug these in here. So I just want to do a few things, which is let me just take a transform here and just want to keep it up. Yeah, maybe scale it a bit. And then let's take another transform and just rotate the whole thing 90 degrees. Okay, there we go. So this is fine. And then I'll take this light, I'll keep it up here. What I'll do is I'll just get rid of the barn door. We'll also lower the intensity a bit. And I'll assign the same material. So the glass material that I have, we just assign the same material, except that I don't want it to have any kind of thickness or whatever. So I'm just going to take the transmission depth to 0 and make this back to white. And yeah, so I have like box 1 and waves 1. Okay. And let me just turn on Octane. So I'll just take this light and we'll just lower the intensity and give it some softness. Yeah. Yeah, there you go. See, so you have caustics in water. Yeah, let me just sort of lower the intensity altogether. Yeah, so again, like if I come in here and now I can get the photon depth low because it's just a surface. So I can get it down to like 3 or even 2 is fine. Okay, and then if I sort of lower I lower the photon gathering and you get like really sharp. And the great thing is it's actually pretty interactive. Like as I move it, you can actually see it move in real time, which is what makes it like super impressive. Okay, so just for fun, so now like let's say if I come in here into my material library, I come into the prism and I'll get the specular IOR higher. So what that will do is it will give more reflectivity to the water, which is stupid. But what you'll get is, see, you'll get like, the reflection sort of happening, and you'll get like reflective caustics as well. You don't usually do that, but yeah, it gives you those options as well. Now, as a final thing, let me just lower the spotlight a bit. Yeah. What I'm going to do is I'm going to add a fog to this. Now, the only rule for using fog in Solaris is that I need to write it out to disk. Okay, so what I have is I just have like a box. So I made this box and I just gave it like VDB from Polygon. I made it into a fog and then I just saved it out to disk. Okay, so what I have in Solaris is yeah, there you go. So I loaded up a volume, okay, and I made like, so I loaded up the fogbox.vdb, which I had saved out to the hard drive. Okay, so if I just plug this in, so there it is, so it's just covering up the box. And let me just turn on the material for it. Or is it on? Yeah, the material is on. Okay, so the material is like a standard, Octane volume shader. This is not a basic Octane lesson, so I'm assuming you know how to make a volume shader, but it's just basically this. It's just the medium volume. I have a low density and I'll keep the step length to 0.5 and I have my absorption at like slightly greenish. So if I'll just temporarily disconnect it and I'll reconnect it so you can see the effect. So let me just turn on Octane. Yeah. And then I can just plug in the volume and there you go. So you have, and the cool part is you actually get volume caustics. Okay. So if I take this light, let's say we increase the spotlight a bit and I'll bump up the multiplier. See, so you can actually see the beams of light. Okay. Now here, if you want volume caustics, you might have to make adjustments to the photon gather. Okay, so like if I come in here and if this is slightly bigger, you'll get the beams to come in faster. And here the photon count multiplier also plays a huge part, because if this is really low, you'll see like the volume caustics take a very long time to clean up. But if I start to increase the photon count multiplier, you'll see like the volume caustics, jump in a lot faster. So you can, again, so just find like a balance. So like 0.015 is okay. Like it's sharp enough. And if the beam is thicker or if the photons are slightly thicker, it shows up in the volume faster. Like that's the whole point. So yeah, so you just have to sort of make that balance of how much, like this won't show up as well because you have volumes inside, but there you go, so now you can get like volume caustics and this, like let's just take this, let's just bring it in really close to this. Yeah, and let's do one thing. If I come in here to the material library, I'll take the base and make it just more darker. Yeah. And then if I come into my water material or the prism material, I'll just up the IORC. So you can see the light reflecting off. So this is all caustics. Like if I was to turn it off, you'll see like you pretty much have nothing. Okay. So this entire beam that you're getting is basically caustics, okay, which is pretty impressive. So yeah, so the lower it is, like the more light passes through, and the higher it gets, the more light sort of like bounces off. So you're getting like lesser coming in there, but it's bouncing off a lot. Water is generally like 1.33 as far as the refractive index is concerned. Yeah, so that's pretty much it. Like, so now again, like as I said, like if I take this, I'll just create a snapshot of it. And if I lower this too much, then it'll take longer to clean up. Like you're getting a lot more detail now in the caustics on the floor, but the overall, like the volume caustics are taking a lot longer. Okay. Like we'll give it the same amount of time. Like this rendered for a minute, so we'll check this for a minute as well. This isn't bad. Like at 0.15 or 0.15 what it was, it's okay enough. Like unless you want it like super sharp. Yeah, so as you can see, like even at a minute of render time, the beams are still not clean enough. Okay, so you have to find that balance. Okay, so like if you're doing volume caustics, like slightly higher is better, or slightly thicker photons are better, because you'll get the beam. See, now even if like 7 seconds, it has managed to bring in. Okay, which like let me do like one final snapshot with this because I forgot to do a snapshot of the previous one. Okay. But if I get it like 0.007 and this was 0.017. So see, at 7 seconds, this is 13 seconds and this is about 13 seconds. So if we check these two, see, so this is, you can see the beams a lot clearer. Here it is still grainy. So yeah, make a choice, decide what you want to do. That's pretty much it. So this is how you can do caustics in Octane.